ഹലോ എന്തായി? എന്താ? Sir Rajesh sir, good morning.
Very good morning, sir.
Shall we start, sir?
Yes, sir. Shall I share my screen, sir?
Yeah. Sir, 1 minute. Saranya ma'am. Start,
Yeah,
ma'am.
sure. We shall begin. A very good morning to everyone and a warm welcome to 5 days FDP on recent trends in medical imaging and communication. With the motivational support of Chief Patrons of the Faculty Development Program, Dr. A.J. Shetty sir, President LMET, and Mr. Prashant Shetty sir, Vice President of LMET, let us begin today's session of FDP. We have with us today's resource person, Dr. A. Rajesh, Associate Professor, KR College of Engineering, Principal of AJIET, Dr. Shantaram Raisi, Vice Principal and HOD of ISC, Dr. Nagesh HR, revered HODs of various departments, faculty members, all the participants from various institutions, and our dear students. I, Sharanya PS, Assistant Professor, Department of ISC, welcome you all for the last day of 5 days Faculty Development Program on recent trends in medical imaging and communication, organized by the Department of Electronics and Communication Engineering in association with the Department of Information Science and Engineering and Department of Computer Science and Engineering. May I now request Mr. Manjukiran B., Assistant Professor, Department of ECE, to introduce today's eminent speaker. Over to you, sir.
Thank you, Sharanya ma'am. Warm good morning to everyone. Respected President of Lakshmi Memorial Education Trust, Dr. A.J. Shetty sir, Vice President Mr. Prashant Shetty sir, all the directors of LMET, Principal of AJIET, Dr. Shantaram Rai sir, resource persons of today's session, Dr. A. Rajesh sir, HOD and convener of FDP, Dr. Gnani, HODs of CSC and ISC, Dr. Anthony PJ and Dr. Nagesh HR, HODs of various department, participants, and my dear colleagues. Heartily welcome to you for the last day of 5-day FDP on recent trends in medical imaging and communication, organized by Department of Electronics and Communication in association with Department of CSC and ISC AJIT, Mangalore. Today we have with us the eminent personality who has worked in both industry as well as academia, Dr. A. Rajesh, Associate Professor, KR College of Engineering, Trichy. On behalf of management, principal, and organizing committee, I express our gratitude to Dr. A. Rajesh for accepting our invitation and agreed to deliver a talk on wireless energy conservation in wireless network. Thank you, sir, for accepting our invitation and heartily welcome to you for this faculty development program. We have with us our beloved principal, Dr. Shantaram Raisi. I am very happy to welcome you to this session of FTP, sir. I extend warm welcome to HOD of ECE and convener of FTP, Dr. Gnani, Vice Principal and HOD of ISC, Dr. Nagesh HR, HOD of CSC, Dr. Anthony PJ, and various heads of all the departments and participants for the session. Now I would like to introduce today's resource person, Dr. A. Rajesh. Dr. A. Rajesh obtained his bachelor degree from Rajiv Gandhi College of Engineering and Technology and MTech degree from Pondicherry University with gold medal and PhD from Pondicherry University under Inspired Fellowship from BST, Government of India. He started his career as an assistant system engineer in TCS and worked there for 9 years and shifted his career towards academics. He has worked in various capacities at Christ College of Engineering and Technology, Pondicherry University, VIT University, Vellore, and presently working as Associate Professor at K. Ramakrishna College of Engineering, Trichy. His research areas are wireless networks, MIMO antenna design, and photonic crystal-based devices. He has guided 4 PhD students and 29 MTech students and has 3 patents to his credits. He has published more than 51 papers in international journals and presented 57 papers in various international conferences. He has a lot of awards and honors to his credits. To name a few, awarded gold medal by Pondicherry University for standing first in MTech among all the affiliated colleges. Awarded gold medal by Pondicherry Engineering College for standing first in college among all the department. Awarded Pondicherry Chief Minister Cash Prize for the best academician performance in MTech Cash Prize among all the branches. Awarded Sun Certified Java courses, Java Professional by Sun Microsystems. Awarded Certificate of Appreciation by VIT University Vellore during academic year 2014, 2015, 2016, and 2017 in recognition of contribution to research through publication in peer-reviewed journals. Awarded Certificate of Outstanding Contribution in Reviewing by elsewhere in recognition of the contribution made to the quality of the Journal of Computer and Electrical Engineering. Awarded Certificate of Reviewing by Springer in recognition of review made for the journal. Awarded Certificate of Outstanding Contribution in Reviewing by elsewhere in recognition of contribution made to the quality of the Journal of Network and Computer Application. He is a senior member of IEEE and member of IETE and life member of IST. With this brief introduction, I present before you the resource person of today's session, Dr. A. Rajesh, and I once again welcome you, sir, for this FTP session.
Thank you, Dr. Manjikiran, sir. Thank you for your very detailed introduction of myself. Whether I'm audible, sir?
Yes, sir. Yes, sir. Over to Sharanya, ma'am.
Thank you, sir. So, whether my screen is visible, sir?
Yes, sir.
Okay. So, very good morning to all present over here. Today, my lecture topic will be on energy conservation in wireless network. Hope you may have been attending this 5 days FTP on various topics, right from the dimensional 2D to 3D and power management in circuits and machine learning based wireless communication. And this topic, whatever we are going to discuss today, will emphasize on the energy conservation in wireless networks. As we all know, our communication has two important resources. One is the bandwidth, another one is the power. So these two has to be utilized optimum so that we can able to effectively make use of the resources of the communication. So that is the motivation or objective why this topic has been chosen rightly in the context of recent trends in wireless communications. So the outline of my presentation will be, I will give you a motivation, what is the need for energy conservation, and a brief introduction, why there is a necessity in the current scenario, what are the energy efficiency, or what do you mean by this green network? This term is becoming very popular in the current IEEE frameworks. And what are the energy savings for wireless network? What are the tech mechanisms available in literature? And what are the techniques? We will see about the mathematical model behind this energy techniques or energy conservation. And then we conclude and what is the current scenario about this energy conservation. So the main motivation towards this particular energy conservation is, we all know that the number of base stations are keep on increasing from one generation to other generation of networks. Right from the first generation, where we have started with the analog, then slowly we moved into 2G, which has been very predominant in terms of GSM and CDME. Then we have moved into 3G, but 3G has not been much there in Indian context, where we moved into 4G. Presently, we are in 4G, and anytime we may get our 5G communication. So normally what we need to understand is, moving from generations, also try to have more number of base stations. We call it as base station site density. So this higher base station site density is one of the important motivation towards this energy conservation. So normally typical mobile network consumes about 40 megawatts. So that is not a slower and small number. So we need to increase the number of grids so that to provide or pump the electricity to meet the demands of these base stations, and most of the cost is for diesel generators on absence of power. So there is also an equal responsibility in corporate to reduce the carbon emissions. When I say corporate, it refers to the service providers like Airtel, Vodafone, Jio. They have the responsibility to reduce the carbon emission and having the environmental impacts of the networks. So we all know that the 5G is highly targeted in reducing the energy or in reducing the power. So most importantly, we need to understand that almost 50% of the electricity is used in radio access. So that is a main catching point why we need this energy conservation. So we can see that almost 50% is used in radio access and others are in the backend operations in the core networks. And so operating electricity is the dominant energy requirement at the base station. And for other devices, when I said devices, here I meant about the base station, and this other devices is meant about the mobile station. The mobile station context, most of the energy has been dissipated in terms of background and heterogeneous traffic. So we all know that we will be happy enough if our mobile is able to give a battery backup of a week. But we all know that on an everyday basis, whether we are we having breakfast, dinner, and lunch, we also need to do the charging of the mobiles, else we can't able to use the mobile. Most probably, if it is a higher battery capacity, the mobile may extend for a day or two. But we will be very happy if we have a mobile that can able to give for a week or a month. So there is a very limited research that is going on in this particular in the case of circuits, but already the speaker might have emphasized what are the power managements in case of electrical circuits. So we will see about the energy conservation in terms of our networks. So one is a very easy or a straight away thing that can be done is by turning off the transceiver when not needed. So everyone may say, okay, just turn off the transceiver at the base station or at the mobile station. But we know that the moment we don't see the availability of the radio links or availability of the signal, we think that the station is down. So that is not a highly feasible having turning off the transceiver, but we need to do some part of it. So we can use ultra short packets, but due to the heterogeneity of the traffic, that too is not that feasible. So again, we need to work on how the traffic characterization has to be done for the communication. So multipath could be derived and used for reaching the destination. Already this has been widely used. And while we are saying about this energy conservation, data that has been transmitted from the source to the destination is ready so that the data could be reached without any error. So we will see about the response delay in getting this data reception. The term which I'm very much saying is the response delay. One is the low energy has to be low, still the delay has to be also low. The delay, whatever I meant over here, is the response delay. The node ideal listening and overhearing should not happen in the network working. That is very important. And this is the last point is much been exploited in terms of multi-hop data transfer. This has been translated in terms of D2D communication, device-to-device communication. So that is how the 5G is going to also be a part of a 5G, the massive machine-to-machine or D2D communication with the multi-hop data transfer. So having said about the conservation means, there is so much of constraints because we know energy is required in every major and mini operation of any type of application. See, normally we are now enjoying during this pandemic, we are enjoying all sort of communication because we have a very good infrastructure to provide all this network. So, but on the other hand, the devices are equipped with the batteries. The batteries do not have batteries do have a limited lifetime. That's what I said in the previous slide. We have a battery equipped devices and we need to charge them on a regular basis. Say example, there are also scenarios in the case of underwater sensor networks. Like, that is another area which has been highly explored, where there is no sockets to provide power as per the requirement. So the energy conservation in this underwater wireless sensor networks is again an important point. those who have been researching, who are having a motive towards that research, can very much focus on this energy conservation. So that's what I said. The fourth point is very important. The battery technology is still lagging behind the microprocessor technology. We may know that we are in the 11th generation of processors, but still our battery has not grown to that particular extent of our microprocessor. So what is much needed at this context is we need to have energy efficient networking protocols that could be able to facilitate this energy conservation. So that is very important as part of our today's trend. So this will give you where we have all started. So I just mentioned 1 decade back. So 1 decade back, there's only a millions of devices. I'm saying about the global context. 1 decade back, there's only some millions of wireless devices. Predominantly, they are used for voice, slowly into SMS, now going into email and mobile TV. Slowly, what happens is now we have billions of devices. So we can see that the wireless networks should able to support or handle all this number of devices in the current context. Now the devices or the base station has to support the Wi-Fi connectivity. Again, should have a seamless wireless internet, social networking, so gaming, and YouTube has been a part of our day. So in today's billions of devices, future, see, as I said, the 5th generation, what is going to be a very big bottleneck is the number of devices getting connected to the network. The devices is not going to million or billion. We have more than trillions of devices due to the IoT connectivity. So that is going to be a real challenge for the wireless network. So this need to be seen as part of this context with reference to application. Here I meant application because the application is the driving factor why this network is growing. If you don't have interactive application, we never go and look into a mobile or a device, because these applications are the attracting point for children or a younger or a elder people, because application is the driving factor for the growth of devices, networks, and so on. So having said about the applications, we also look into the devices. As I said, more devices. We are seeing like foldable devices are coming in today's market. Even Samsung, if you can see, the devices can be folded for a larger screen or unfolded for a larger screen. And for healthcare context, we know in this pandemic, this networks, wireless networks or devices are helping a lot for the needy or elderly people through the ICT technologies. And as I said, in case of industrial or in case of all other applications, IoT is playing a vital role. And finally, they are moving towards a CPS, cyber physical system. And you can see that to meet the energy demand of all these devices, networks, and applications, we need to have a very good infrastructure to provide the need energy. And this energy should also in line with the environment. When I say environment, we should reduce the carbon CO2 emissions as part of this energy productions. So this is where, so this is very interesting to see. The communication has started something like people to people. We want to communicate, like I am communicating to the set of participants. So here, then slowly the communication has become like people to machines. Now, the 5G or the next generation, mostly the communication will be machine to machine, so or device to device. So this is because ultimately we are the end people who are going to benefit out of it. But the type of communication has moved from people to machine to machines. This transition has to be noted because the networks should be able to handle more number of devices than the people in the globe. So that is one important thing to be noted down. The networks should be able to handle more number of machines or devices than people to have this connectivity. And this scenario will say, see, right from we woke up from the bed, then again go to bed, what are the devices that has been a part of the wireless network? See, we know that, see, when I say alarm clock, we are setting the alarm clock. It can be either Wi-Fi enabled or Bluetooth enabled. So that is going on. Nowadays, we also have in terms of mobile itself. And there's a coffee maker which will exactly turn on its turn on when it becomes 7 o'clock or 6:30. So it is all having. So a coffee maker which is all set saying that it has to go through this particular one. Then we have a something like an electric toothbrush, a refrigerator, which all set to meet the demands of the persons. So that is very important. Then it goes to the car. Car will, we know that the car has been fully automated in the current context. It will check for the availability of the diesel or petrol and also the maintenance conditions, and it will be reporting. The car also has the information regarding the map traffic in real time. So it will say what route to be taken that has to be chosen by the person to reach the office. And now cell phone has become a part of it. I don't want to put a separate thing over here. So see, right from in the workplace, it is completely networks, a highly networked environment, right from the VoIP, voice over internet protocol phone, to the computers or HVACs, where we control the temperature and lights for maximum efficiency. HVAC is one important thing that corporates are looking into to reduce the energy consumption. And vending machines, printers, building security. Then again, after coming back, we can also set remotely what should be automatically set the cook cycle with RFID recognition, the TVs. Finally, we go to the bed. So from waking up till again going to bed, we have a lot of devices, and it has to be noted that the networks are trying to support all these devices. And more importantly, all devices should, or some of the devices are directly connected to the power supply, and many of them are battery powered. So in that context, the energy conservation is very important. So here, this is one important slide, how the data being used by the person is getting varied from one person per month in case of 2014 to 2020. But 2020 is only a part of it. Actually, after this lockdown has happened, the number of GB or data that has been used per person per month has been grown tremendously in terms of 100 times than what it has been displayed over here. So this is very interesting. So it has been given by Ericsson on prediction actually, but it has been highly correlated with currently what we are using. So it has started all with 410 MB per person per month in 14. Now, say Jio or Airtel is giving 2 GB per day, but still we don't, we are not out of data. By afternoon itself, we can see almost most of the data is getting depleted. Why the data has been getting depleted? Because the devices or the mobile devices is not meant only for voice call. We are doing social networking, web browsing, video streaming, gaming, wireless gaming. See, these are all the killer applications. Means that, see, voice is not a killer, but SMS is a killer application. What do you mean by killer application? In the sense, it is not the killer application, the application with which exactly try to reduce the resources of our communication. And I say resources, the application try to take more amount of energy, or the application which try to have more, which take more amount of bandwidth. So you know the video VoIP or video conferencing, it is trying to consume more amount of data, or the social networking, which try to have a heterogeneous type of network traffics. So this can be seen an extrapolation that this will be 5 times increase until 2020, 25 times increase until 2025, 125 increase until 2030. This prediction has been made without having this pandemic or lockdown into picture, but now this 25 times or 100 times has been met by 2021 itself. This 125 times in 2030 has been there in 2021 due to this unpredictable lockdowns. So this slide mainly says about the things that can be connected. Now, when we try to browse our Amazon or any other Flipkart, all those things, now they are trying to have an advertisement saying that any devices can be IoT enabled. You just buy this particular plug and we convert your devices into IoT enabled device. So that is the starting point, how all the devices, what we are having in our home or household will be converted into IoT enabled devices. Saying about conversion of these devices into IoT enabled devices, or more things are being connected to the network. I just emphasize more things are being connected to the network. Having said about this, what is happening is the energy or network has to conserve or has to provide the connectivity to all these devices, which less energy conservation. That is the main point over here. So you can see that per hour, how much energy is getting being used by these devices. So now we are saying about the people are getting connected to the things like people to machine communication. But as I said, very soon or now, even now we have many devices having things getting connected to things. Why I try to put this term things is, so it is not only from the Internet of Things, it is also any devices to name can be get connected to the network. So as I said, if you go in a rash driving, that will be immediately informed to the police and they will take an action. But everything will be automated, as we are having in many other countries. Based on the fuel availability, it will say what is the nearest fuel station, and it is also will alert for the maintenance. So we need not to control anything from our end. The devices will make based on artificial intelligence and machine learning approach, they will try to make use of the network to get the things done. So that is how the future or the 5G networks is going to be things getting connected to the things. So this is very important. The networks are changing. So more nodes, more connections. We used to have a very important thing, anytime, any place. That is what all about mobile communication. At any time or any place we are getting connected. Now the 5G is all about anytime, any place, anything is getting connected. So already slowly moving towards our 5G, which we used to call as smart networks. So when I say about the things, one interesting factor is that, so what is a very important factor to be noted down in these things is that in 2003, the number of people on earth is more when compared to the things or devices. The 2008 is a very important year. I have not mentioned here. 2008, the number of things connected exceeded the number of people. Means that more number of devices are getting connected to the network than the people on the earth. 15, you can see so much of things, and in 2020, around 50 billion things are getting connected to the number of devices per person is around 7, approximately 7, and it is a growing factor. So that is what I mean to say, why there are more number of devices when compared to the world population. So this is the alarming thing, what happened in 60 seconds. Even some persons, you might have come across this particular slide. Very interestingly, see in 60 seconds, so you may know that 100 plus new LinkedIn accounts are getting created, and you can see number of voice call that has been made using Skype, more than 3 lakhs minutes voice call and Skype, and more than music streaming on Pandora, and you may see that 13,000 plus application, iPhone application download, and it is in terms of lakhs and crores in case of Android based, and you can see 600 plus new videos are getting uploaded as well as, and many are getting downloaded. You can see about the blog posts and emails that are sent. That is very alarming. So you can see, right, 168 million emails are sent in 60 seconds. And how much search queries? More than 7 lakh queries are being done in Google. So again, I just want to make a point. This is all taken, the data has been taken before, like pandemic, but this is much more higher, just to map what is happening in the network. So I need not to put more emphasis on this IoT platform. Why I need to say about this is, this particular, many things are getting connected to the internet, and the more thing that has to be noted down here is the gateway. the gateway is a very important thing where the more focus on energy conservation when more things are getting connected to the network. So when I say about the things, the more important thing is the things are having the different forms. So we know RFID tag, so they're called as tagged things. Some things that can able to sense the feelings, actually feeling things. Some examples of sensors that has been integrated along with the smartwatch, primarily collect data from the environment or from our humans. That is feeling things. Shrinking thing is due to nanotechnology, the things are getting more and more miniaturized and more number of things are getting embedded as part of the device. The final thing is very important, like the things started thinking of things started thinking. So the embedded intelligence in devices through sensors have formed the network connection to the internet. So that is very really interesting because the things have started thinking. So we need not to make more of the decisions. The things may help us in making the decisions. So this is something like what communications we have right now. We have both fiber communication. Most of the broadband connectivity in college as well as in our corporates is based on fiber optic, and at most of the homes we have our wireless communications. And for this RF based communication solution, I have a Zigbee based 802.15.4, wireless LAN based. We have different variants of wireless LAN, Bluetooth and NFC by means of RFID. So we have different communications to communicate, and we have different forms of networks. We don't have a single network. We have a wireless sensor network, we have a MANET, mesh network, WANET. So there are different networks which try to group the devices. And having said all about this, what is very important is these devices are distributed. All nodes need to perform networking related tasks. So that is very important. Networks are distributed in most of the context. Cellular network alone is mostly centralized. Most of the networks are distributed. So here the network connectivity goes from this devices or network connection between the devices towards the gateway to the internet. So you can assume this as a home. I will give another slide which gives a complete picture how the devices are interconnected and given to the gateway, which in turn is getting connected to the internet. So here from the protocol stack point, you need to really understand the devices and the gateway. So why these things are taken before the energy conservation is you need to really work on certain layers of the protocol stack to make this energy conservation. So that is the reason why I have made this particular slide on protocol stack, because while coming into the energy conservation strategies, this is going to be playing a vital role. So as I said, simply switching on the transceivers or switching off the transceiver won't provide the energy conservation. We need to go up the layer of the protocol stack to design different power saving models or classes to do the energy conservation. So while doing so, the gateway has a very peculiar feature. So we have a dual protocol stack. The protocol stack is not single, as in the case of things or devices or mobile devices. The gateway has a dual protocol stack. See, we need not to see the gateway as a different thing. If you have a Wi-Fi hotspot or if you have a Wi-Fi router, it is having this particular gateway functionality. The Wi-Fi router, what we have in our homes, have this gateway functionality. On one end, it is getting connected to the Ethernet by means of IEEE 802.3 protocol stack. On other end, we are getting connected to the devices either by means of wireless LAN or Zigbee. Here, this 15.4 is mainly for Zigbee based connectivity. And most of the times in our home, we are having this as IEEE 802.11 based physical MAC layer device. So this is how the information is getting transceived. So you can see that when it comes to device, it need not to go through all the layers of the protocol stack. It goes from the main device and only at the network layer, then goes into the gateway and through the server. So this is very important, how the packets is getting traveled over the devices, how the packets are getting traveled over the devices. So here, as part of this, there are so much of IoT devices for this particular connectivity, right from indoor electrical wiring like Ethernet, Bluetooth, Wi-Fi, as I said, 3G, 4G devices, satellite phones. Any devices you can name will fall under the category of these devices. So as I said, why need to focus on this particular energy efficiency or energy conservation? We seen that it is highly dominated by network infrastructure, which is keep on increasing continuously from generations as well as the number of devices. So on the other end, we are also going for higher data rates. You know that the 2G mobile can able to have a battery backup for more than 4 to 5 days. It cannot be expected from the same 5G, 4G device or 5G device. The reason is the higher data rate that these devices support also is one of the reason for energy efficiency or energy conservation. So this call for high energy efficiency. So how to define this energy efficiency or energy for conservation? Because that is very important from a research perspective. So how to define this? So something like energy efficiency is defined as average sum rate, which is nothing but the spectral efficiency, the bits per seconds, but not it's not like spectral, it is bits per seconds per cell. It is the average sum rate. Normally in case of spectral efficiency, it is bits per second per hertz. But here it is the energy efficiency in terms of the ratio of average sum rate from one particular cell and how much power that is consumed in that particular cell. Power consumption in terms of joules per second per cell is defined as this energy efficiency. So to put simply, the amount of data transmitted over the consumed energy. The amount of data that is consumed over the amount of data transmitted over the consumed energy. So that is why we take per cell. We don't say per hertz because there is no cell coming into picture there. So we will see a model developed in this tutorial, how this particular energy efficiency can be modeled, how this energy efficiency can be modeled with reference to traffic characteristics. So this one thing which says about the load independent efficiency. So someone might have think of, okay, I may go for load dependency. I can go for load dependency, but you can see that the traffic characteristics is a very important factor. The traffic characteristics is a very important factor over the time. So certain points of time there is a very low traffic and certain point there is a very high traffic, and this is highly a factor based on a particular region of interest. So there should be the future networks, the contemporary networks is relatively efficient at a high user load. When the user load is very high, the contemporary networks or the conventional networks will work, but very inefficient at low user load. Very inefficient at low user load. So the future networks should be more efficient or more energy efficient irrespective of the current load. So that is a point to be noted down here. So how to design this particular energy conservation is, I should characterize the traffic and it should be irrespective of the, it is not independent, it is irrespective of the load of the network, irrespective of the load of the network. So there is a high call for this particular energy efficiency in case of future networks. So this is something like energy efficiency. Where are this energy efficiency can be implemented? It can be in agriculture automation, energy consumption, security, building management, telemedicine, smart homes, M2M and wireless sensor devices, embedded mobiles. Everywhere you can try to think about having this energy efficiency. So another thing is why it is important from a global context is US National Intelligence Council has made one particular announcement that IoT based devices or network connectivity for wireless network is going to be one of the disruptive civil technologies with potential impact on national power of USA. So that is going to be one of the real interesting fact, because it is going to be a disruptive civil technology, means that it is going to be a part of everyday. So by 2025, internet node may reside in everyday things, food packages, furniture, paper documents and more. So in future, you may think of having a paper, mainly like where we are trying to write all our exams or whatever may be, will be a embedded one, and there won't be much on the malpractice factors that has to be considered in the current scenarios. So that is where like it is going to be or may reside in everyday things, and to the extent that everyday objects or things become information security risks, the IoT could distribute those risks far more widely than the internet has to date. So someone may be saying that there is a risk with this, making all the devices getting connected to the network. But one important thing to be noted down is already internet is itself has its own risk. Still we are doing about mobile banking or internet banking, because amid the risk, we are trying to make use of the facility. So for certain people who are saying there is information security risk, there may be a very good solution with this IoT net devices. So when I try to map this wireless network solutions, certain things has very good market proliferation. What I mean by market proliferation is, although certain things are very interesting from our research perspective, only few things have highly having a market potential. See, most of the times we try to say to the students like to be an entrepreneur, because that is a very good motivation that we can give to the students rather than getting placed in some companies. So they should look into the market proliferation. You can see that, say example, the smart TVs has very high market proliferation. Smart lights, even Philips and many vendors started selling about the smart light, smart refrigerator. This has more proliferation when compared to the smart ceiling fans or smart air coolers. There are certain areas where we can ask them to focus, but here the energy management is very less, because if you don't want to conserve, if you want to conserve energy in the case of smart light bulbs, yeah, there is a ways by having a sensor which senses the presence and absence of the object, but still the management responsibility potential is low. But where we can highly focus is over the smart street light, home building automation, smart gazers. This is an important thing to be noted, where there is a high need for this particular energy conservation, smart sockets. So you can see nowadays there are many advertisements regarding the sale of this smart socket. Even as I said initially, in Amazon and Flipkart, there are many places where this thing is getting advertised, and so on. So the applications start from the transport and logistic to healthcare and futuristic like a robot taxi, which has already been there in most of the countries, city information model, and some game-based things. So this is some idea about the smart home is all about. When I say about the smart homes, you can see here the smart home has a motion sensor, a door control, and you can also see about the light control. Energy management is going to be a part of it. The energy management or conservation is a part of all this home environment. Still here also, in the case of intelligent transportation like a robot taxi or whatever may be, so everything are interconnected to the network. Everything are interconnected to the network either by fiber optic or microwave or by means of satellite communications. So you can see that there are many interesting videos that have been available online to see about how this intelligent transportation is being visioned in coming days. And ultimately, it goes into the smart city. Having a smart home and environment will make a smart city. And fully, one paradigm is with reference to IoT-based wireless networks with many visions. Here, there are many bodies, many groups that have been looking into this particular energy conservation. For this, having smart cities, smart home, smart transportation, having a common architecture. So you can see very big vendors started looking into the energy conservations like BP, Bosch, and IT, and like this CTC, Qualcomm. So everyone is looking into their own place where they can able to contribute towards this net architecture. So as I say about the smartness, they should have a green network. The smartness should not go by increasing the energy consumption. So where there should be some energy conservation. So here the smart city goes with a green wireless network. So city development in a global scale is there. So reducing the cost and the energy resource consumption, and more importantly, to have provide sustainability and low carbon solutions. How this network has to grow is the low carbon solutions. So there are different dimensions where you can focus, and mostly my focus will be on this network technologies. So you can go for like a cloud platform, embedded hardware platform, and identification of technologies and data management. But my focus will be on this network technologies. So this is a very interesting slide which came. What are the 4 fundamental trade-offs? Saying that I want to do the energy efficiency, I should not go compromising the spectrum efficiency. The trade-off should not be there. Saying that I need a very good energy efficiency, I should not have a less spectral efficiency. Or bandwidth consumption. Saying I need to consume more power, or say I want to consume less power, the bandwidth should not be consumed more. And the deployment efficiency, most importantly, the latency. Saying I need to conserve the energy, I should not increase the latency of the network. So in terms of spectrum, bandwidth, deployment is how the network has to be structured, like infrastructure or architecture of the network, and the power delay trade-off. So there are certain general principles that is part of this wireless network. What do you mean by principle is turn off the facilities that are not needed. Even we used to say to many people, just turn off the fan or light when we are not at that particular place. But here it is not about simply turning off. It is all about scheduling the duration of the device or the network. Scheduling the duration of the devices or the network. Send only data that are needed. It is not from our perspective. It is from the device perspective. Send data that are needed. Because the moment we transmit any data, we expect it to be delivered. It is not from our perspective, from the device perspective. Minimum length of the data, minimum length of the path, mainly for energy efficient routing, energy efficient architecture, something like data fusion, trade-off processing, like compressive sensing. This is very much focused in the current trend with the compressive sensing. And with this advanced communication techniques like MIMO and massive MIMO, we need to look for an alternative modulation technique which has its equal impact over the physical layer of our energy conservation. So finally, having a green power sources. So this is from a wireless network architecture, how this green wireless network architecture is supposed to be configured. Mainly this you can look from a 5G perspective, because there are so much of MTCs and machine type communications happening at the core network as well as in the radio access network, with a lot of IoT applications coming into picture. And this is mainly for ad hoc communication. This is mostly for infrastructure communication, how this green wire network is going to be structured from a coordinated or from a centralized point. In a distributed point for ad hoc communication, how the device. So this is one framework which has been implemented even in a Delhi scenarios to have a complete Delhi getting connected with Wi-Fi hotspots. So you can see there are different devices providing network connectivity. Not only that, they also try to control the lights automatically, and they are getting connected to the network, and in turn this network means the base stations, which in turn towards the cloud. So that is the one ad hoc communication in green wireless network that is being expected. Not only that, the sensor devices are part of this particular framework will be switched on only on the presence of any objects or in presence of any persons. So that also will try to reduce the energy consumption. So this slide will give a motivation in terms of how much energy that is getting conserved, or what is the standby power at the gateway panel, or what is the standby power for mole pointed controller, what is the standby power for IoT devices. See, something like so that I already emphasized on the gateway. why this gateway is very important is, see, we need not to go for a long distance communication. In the case of 5G femtocell based or relay based implementation, we always try to have a gateway into picture, and that gateway is going to have a control over the network connectivity. So you can see in the case of gateway with the feeder panel or the gateway for individual LAMP controller, like the LAMP controller is what I said in the previous one, or WPAN based Wi-Fi 2G 3G LAMP controller. You can see there are certain mechanisms that can able to reduce the power as compared to the conventional means of centralized communication. As in the centralized, the ad hoc, which is mainly focused on this femto based configurations, can able to reduce this particular power. So something like this mesh network has been very attractive when compared to this particular centralized in most of the cases, because this particular power conservation is there. So the standby power is also called as the leakage electricity or vampire power or phantom power. It refers to the energy drawn by an electric device or mobile device when it is not in use or when the device is in ideal mode. So this is very important, because why? See, many times we don't focus on standby power, but say even our mobile is not in a working condition or in the active state. Any device can be in any one of the three state on a broad perspective. One is the active state, another one is the sleep state, the third one is the ideal state. When I say active state, you are actively using your mobile so that the mobile is getting connected to the network. When I say active state, the mobile is getting connected to the network since you are actively working on the mobile. Sleep state is something like you are not using the mobile, but still, you are putting the mobile in something like idle, not in ideal condition, without having any network usage. There is one intermediate stage called as ideal state. This ideal state is something like your mobile is getting connected to the network, but you are not doing any active conversations. So this ideal state is, ideal mode is to be much explored, because that is the reason for this standby power. So where we can able to reduce the standby power to a greater extent in the case of mesh connectivity or in the case of ad hoc connections. But this ad hoc connections is not feasible for all type of networks, all type of applications. So when I see, the most focus is on the gateway, because the 4G or 5G mainly highly depends on how this gateway are being configured in a larger extent. So the gateway has a multi-band support. When I say multi-band support, it can able to support LTE, Wi-Fi, Bluetooth. BLE means Bluetooth low energy, Bluetooth low energy Z-wave bands. So which has multi-antenna or MIMO based antenna configurations. And also the RF chipsets is been separate in terms of its modem processor, because the RF chain is different for this wireless PAN, wireless LAN, as well as in LTE based context. So this is a multi-RAT operation. It is having a multi-radio access technology operation. So a single gateway can able to get connected to different networks, and they can able to give the proper connectivity. So this particular one will give you so much of research that has been gone with this particular gateway, because in a wireless WAN context, in a wireless LAN context, in a wireless PAN context. So you can see here, this particular one is having a gateway structure, and the power conservation or energy conservation has been much focused on a wireless WAN, LAN and PAN context. So say example, the paging cycle and DRX mechanism. The DRX is the term discontinuous reception, is one of the means of energy conservation in LTE networks. In 4G based LTE networks, how we are trying to conserve energy by means of a DRX mechanism. So the 3GPP MTC, machine type communications, IoT based gateway, and management of heterogeneous radio interfaces, everything focused on this particular energy conservation in this network. So since the gateway has a multi-protocol stack, I already said about the dual protocol stack, but this gateway of 4G or 5G will be a multi-protocol stack, will have the stack for PAN, LAN as well as LTE networks. So we'll directly now come into this particular, how this energy conservation is being done in a radio access technology in the case of our broader context. When I say broader context, it is wireless wide area network. It is wireless wide area network. Simply, I can put it as a LTE network. I can simply say it is a LTE network. We can see how this power management is done in a LTE network. So here, as part of this, what you can see is this LTE network is making use of discontinuous reception. It is making use of discontinuous reception. So here, what do you mean by discontinuous reception? We will see. So when this discontinuous reception is getting enabled is during the RRC connected state of the LTE protocol stack operation, during the radio resource connection in the connected state. So this is mainly as part of the signaling mechanism in this mobile or for mobile device based LTE connections. So here we will see about how this energy conservation in LTE with this DRX. DRX, as I said, it is meant for discontinuous reception. DRX is meant for discontinuous reception. So those who are in from a research perspective can more look into this DRX from a 5G perspective, because 5G not only say about the discontinuous reception, it is also saying more on discontinuous transmission in the case of our IoT scenarios, or in the case of M2M, machine to machine or machine type communication scenarios. So those who are into the research of this energy conservation can very much focus on this particular part of, and most of our discussions in the coming slide is based on this DRX. So LTE spec provides two types of mechanisms for energy power management or energy conservation. So LTE spec provides two mechanisms for power management. One is the ideal mode, another one is the DRX mode. So we have two means, one is the ideal, another one is the DRX. So as I already said, why this ideal mode has to be focused more is since it has more impact on the standby power. Because the standby power is going to really consume a lot of energy. So even you may wonder, I have my mobile, I'm not using my mobile, still power is getting consumed. Because there is an ideal mode connectivity in the mobiles, which is making use of most of the powers. So the 3GPP forum has made an emphasis on this particular ideal mode and DRX mode. DRX is the predominant energy conservation mechanism in LTE. DRX is the predominant energy conservation mechanism in LTE. So user equipment can enter the ideal mode when the user equipment is no longer actively connected to the E node B. So this E node B is a term mainly with reference to LTE. Earlier we used to say base stations. It is a evolved node B. E node B is the evolved node B. The network or the E node B is still able to keep track of the user equipment through a mechanism called as paging. So the paging, the moment you heard about paging, everyone may think of a pager. Pager is a very older ways of communicating with the devices, but the paging is still an effective mechanism when you are to keep track of the user equipment when the user equipment is in the ideal state. Very simply, as I said, there are three states of the mobile. One state is the sleep state. Sleep state is the state where the transceivers are no longer active. The transceivers are no longer in on condition. There's another state called as wake state. There's another state called as wake state. Wake means the normal operation of the mobile. One intermediate state called as ideal state. The ideal state is the state where the network can keep track on the mobile through paging. So just you need to remember the wake state, sleep state, and the ideal state. Most commonly, these terminologies may be also be there in other power managements. So when this DRX will be triggered, that is more important. When I will be triggering the DRX. The DRX will be triggered when a timer in our mobile, the DRX is triggered by means of inactivity timer known as DRX inactivity timer. So even most of our mobiles are having this functionality of this DRX. If you just go and look into the power management options of the mobile, but they won't say like DRX, they will say power management. They will simply say power management. So how this DRX is getting triggered is with the inactivity timer called as DRX inactivity timer. What is the range of this timer is 1 milliseconds to 2.56 seconds. But the values in between are not continuous, means that there is no continuous way of connectivity between the range. They're discrete values actually. So here the DRX is triggered when the timer expires, or there is an inactivity timer that expires between a range from 1 millisecond and 2.5 milliseconds. When a user equipment receives any data, say example, your user equipment is in a sleep state. The moment the user equipment has to receive any data, the inactivity timer has been reset in the user equipment. It has to be reset. So how this is being carried out? What is the frame structure? What is the frame structure to do all these functionalities? We will see. If the DRX cycle is kept too long, there is a caution. If you are keeping the DRX for a very long duration, in many scenarios, say example, you are during night time or during certain periods where you need not to want your mobile to get disturbed, when the DRX cycle is kept too long, I mean many scenarios where we can face with network re-entry. So it's a caution. You should not keep the DRX cycle for a very longer period so that you are conserving the energy. But that will result in what? Network re-entry. You know that the moment you switch on and switch off your mobile, you go for a network registration procedure. And the frequent network registration is called as network re-entry. And that is one of the alarming point to be noted, where there is more amount of energy conservation. So the power management in LT is LT or LT advanced is being discussed as part of energy conservation. So as part of DRX is nothing but discontinuous reception. The DRX itself has two period. One is called as on period, another one is called as off period. Normally the user equipment monitors the channel for data and control activity, and the E-Node B is able to exchange data with the user equipment. So when DRX is in on, DRX itself is activated to make the mobile in the sleep state. But within the DRX, I have some duration or some time called as DRX on period, where the user equipment can monitor the network, whether it has any data to be received, so that it can able to exchange the data with the user equipment. During the DRX off period, the user equipment will simply put all the transceiver circuitry, transmitter and receiver antenna circuitry in low power mode. And this low power mode is a duration where the E-Node B cannot send any data to the user equipment. So it is something a state where the network cannot disturb the mobile devices or user equipment. So when this DRX can be terminated as soon as the user equipment sends uplink data or receives downlink data. See, normally it will immediately get terminated when you are just taking your mobile and started sending any data. Sometimes if a mail has been to be delivered to your mobile, So in that case also the DRX mode is terminated. So in DRX cannot be enabled during an active data exchange without restarting the timer. That is very important. See, when you are actively having a data exchange, the DRX will not be enabled. So when I say about the on state and off state of the DRX, there is also another subcategory within the on state and off state, mainly within the off state, called as short DRX. So LTE supports short DRX as well as long DRX. DRX stands for discontinuous reception. Just I'm reiterating on that. The short DRX basically allows the user equipment to have a short DRX cycle, and it is predetermined number of cycles only. So that is very important, because why this has been why this framework has been designed is mainly to have to make the mobile not to be in a sleep for a longer duration. Initially something like we may make the device to be in a sleep state for some duration. If there is no data to be delivered, then we can make the mobile to be in the sleep state for a longer duration. The idea is that, so you have a short DRX as well as long DRX cycle. Short DRX is, it is only for a predetermined number of cycles. So long DRX means a cycle which is much longer than the DRX cycle. So more amount of power savings can be achieved, or more energy can be conserved in this long DRX. But what is the trade-off? When you put your mobile in the long DRX, what happens is more amount of time that may lead to the higher response delay. That may lead to the higher response delay. So that's what has been said over here in the last point. Short DRX was introduced to reduce the delay, because in certain applications or in certain activities where to occur very soon after initiation of DRX. Say the moment you initiated DRX, you put your mobile in the sleep state. But what happens? That may introduce a delay. So you need not to put a mobile immediately in a long cycle. You just put it in a short cycle. You just monitor whether there is any data to be transmitted to the mobile from the network. So that is what is meant as short DRX, and that try to reduce the delay to a greater extent. But it's a trade-off. Longer DRX has more power saving, shorter DRX has less power saving. There is a power saving, but it is a lesser quantity. So this is something like you can visualize how this from a frame. In a frame, how you may know that in LTE frame, how this may happen. So here you can see some subframes, on duration subframe, and this is a off duration subframe. Subframe means, on duration means in the listen state, and here you can see there is a long DRX cycle. There is a long DRX cycle, and there is a again long DRX cycle. Within the long DRX cycle, you have some duration mainly for the on duration subframes, mainly for the on duration subframes. So here, what happens is the physical downlink control channel, and you know there are many number of channels or a control channel and data channels available as part of LTE protocol stack. So in this particular downlink control channel will inform the user equipment that there is some data. There is a data to be transmitted. So on this reception of this particular information during the on duration subframes. See what happens if I receive this during this off duration. That will introduce a delay in the network. So if say we will see about that in the coming slides. So I'm receiving a PDCH during the on duration. So what happens? That will reset the inactivity timer. Means that there is a continuous reception of subframes. So this DRX has been made from the sleep state into on state, and I have a continuous reception of subframes. So having received all the frames or having received all the data, what happens is, again, I want the timer expires. Just make a note, the inactivity timer expires. The moment I have an inactivity timer expire, I don't put my device in a long DRX. Please look into this. On this timer expiry, I don't put the device in the long DRX subframes. Instead, I go for short DRX subframes. Because initially, I may expect some more data. So if the data has been the sleep state has been very long, means that will introduce a delay. So I initially put in terms of short DRX. Having seen that there is no data, I put the device in a long DRX cycle. The device has been made in a long DRX cycle. So this is the basic 3GPP DRX mechanism as per the 3GPP specifications. So you can also go and look into the 3GPP releases, 12 or 13 initial releases, because LTE 8 or 9, LTE is mainly for release 8 and 9. And even in release 8 and 9, you can have the glimpse of this particular energy conservation. So looking more detail into that on a micro perspective. So here, this long, short, I have a reception. The same thing, I just put it in terms of more informative here. Long direct cycle, short direct cycle. And here I try to have the terms. TI is the inactivity timer. T suffix I is continuous reception inactivity timer. So that will give information when I have to start the short DRX. So again, I have one more timer. Earlier I said there is only one timer, right? Inactivity timer, but I'm just going a bit detail into it. So DRX has both on and off duration, and that off duration will be enabled based on the inactivity timer. I have two type of inactivity timer. One is called as continuous reception inactivity timer. Another one is called as short DRX inactivity timer. When this continuous reception inactivity timer is enabled, when I don't have any data, this particular TI expires, and what happens? The short DRX cycle will be enabled. The short DRX cycle will be enabled. Again, here this inactive timer starts and it expires. On the expiry of the inactivity timer, the DRX cycle will start. What happens? The moment the inactive timer expires, the short DRX inactive timer starts, and there is again an expiry of this particular timer. Once this timer has been expired means it has reached its value, the long DRX cycle will be activated. The long DRX cycle will be activated. So you have to look into this particular details because you need to know exactly how this frame durations has been controlled based on the timers, based on the data transfers. So the more research focus is on this, how to characterize this particular timer, when to start and when to stop, what is the duration of the cycle, how to characterize the traffic in the current context of our 4G and 5G networks or heterogeneous traffic. These are the research directions where you can mainly look into this particular DRX. And so this will give you some insight regarding there are almost 8 to 9 application classes in LTE. So those who are working in LTE may think about why would there is no 5 classes, but why I have 5 classes is, so I just put combined together about the certain classes of LTE so that it looks simple. But if you look into the actual LTE application classes, you have more than 8 classes. So here you can see the class 1 is mainly for a multiplayer interactive gaming. The class 2 is mainly for VoIP and video conference. Class 3 is for streaming media. Class 4 is for browsing, web browsing and instant messaging. So normally instant messaging you may be doing, we often do. And class 5 is for media content downloads. So why this application has to be explored as part of this DRX? So as I said, the data transfer or the traffic characteristic has to be understood to formulate these particular cycles, which in turn give the energy conservation. So you can see the application have their own bandwidth requirements. Certain things have, say, and look into the bandwidth. But if you look into the streaming media, I need to have more bandwidth in terms of data rate. Bandwidth is not in terms of hertz. Here I look into the data rate. So normally in terms of 2 Mbps, and web browsing, it's a variable bit rate from 10 kbps to 2 Mbps, and media content is more than 2 Mbps. So based on the type of data, based on the type of file we download, it is more than 2 Mbps. So based on the rate, and there is also an equal impact on the latency. See, there are certain things which are highly delay sensitive. When I say highly delay sensitive, there's interactive gaming, VoIP, video, and mainly these two, interactive gaming and VoIP and video conferencing, are delay sensitive. Why I call it as a delay sensitive application? Because it is not tolerable to any sort of delay. See, I'm taking some conversation. If that is reaching you after a few seconds, you may not tolerate that. So they are delay sensitive application. But these are delay insensitive applications. If you look into the streaming media, web browsing, media content, they are delay insensitive. See, I may stream a data. Sometimes the streaming may take some time also. So delay sensitive applications, delay insensitive. These three are delay insensitive, and these are delay sensitive. And there is also a very important thing to be noted on the jitter, where Jitter is nothing but the variations in the delay. Sometimes I don't expect any variations in the delay. But in the case of streaming media, already it is delay insensitive. But for that sake, I may not expect a more jitter in the network. More jitter in the sense, if more the same delay is happening recurrently, I may not be happy about that. So the streaming media is having more emphasis on the jitter. So based on the quality of service classes like real-time polling service or unsolicited grant service, non-real-time and best effort services, we need to understand the type of application and this particular rate and latency and jitter to characterize the data. So having looked into these applications, we go into a much more deeper level of this particular DRX parameters. And I say deeper level, what I mean to say is here I have a short normally I said about the inactivity timer. Now you may be somewhat comfortable with the terms associated with this DRX. So that is the idea why I have given a very macro view of DRX, but now I'm going into the more detailed view of the DRX. When I say more detailed view of the DRX, you can now understand what is this start inactivity timer. So what happens is on this expiry of the timer, I reset the inactivity timer. What is the need for resetting the inactivity timer? On looking into this particular frame, you can see the user equipment is in active state. So you know that the PDCCH is delivering the data over that particular channel. So what happens? The inactivity timer has been started, but I need to reset the inactivity timer due to the fact that the user equipment is in the active state. The user equipment is in the active state. But what happens is immediately after a certain duration, what happens? I don't have any data. So the inactivity timer expires. What happens? Immediately the short DRX starts. So the fourth point is all about the start of short DRX. Fifth point is all about start of short DRX cycle. Fifth is all about start of short DRX cycle. Then what happens? You know that there will be inactivity timer of the DRX, short DRX. So this is the inactivity timer of the short DRX. So on expiry of this particular timer, I have long DRX, and this keeps on going till I have some data to be delivered to the mobile. So having looked into this particular portions, whatever I have during the DRX is called as the listening period. These portions are called as listening period, and these portions are called as sleep periods, deep sleep, because I don't have the facility to receive any data during this period, but I can receive any data during this particular period, during this particular frame duration. So that is why there is a decode success during this duration, and there is no any such thing happening in this duration. So that is what I designated by means of on duration and off duration, on and off, and this duration is a variable factor based on the traffic. So say just give an example, what can be the choice of listen and sleep intervals. So having understood the listen and sleep, listen I mean here, sleep I mean here. So listen is the on duration, sleep is the off duration. So from a very starting research perspective, you can think of, you can divide this into different regions of interest. You can divide this into different region based on the duration of sleep interval and listen interval. So one thing we should not forget, the more the sleep interval, more the energy conservation, more the listen interval, more the power is getting consumed. Alternatively, more the listen interval, the delay is getting reduced. More the sleep interval, the delay is getting increased. So that you need to understand regarding the sleep and listen. The L stands for listen, S stands for sleep. So I can divide this particular region into different, divide this particular frames into different regions, saying that the region 1 with having a listen, some sleep, something on an exponential increase. The constant listen, the listen is constant duration. That's why I have a term L, but sleep is not constant, it is a variable factor. So I have S1, S2, S3, S4. So you can see there is an exponential increase of the sleep interval with a constant listen interval. So you can call this as a region 1. It is very much different from the conventional because I don't have a fixed amount of short as and long DRX cycles. But here, initially, it seems to be like a ultra short, ultra like something long and very long, something like that. The region 2, why? What is the reason why I have different region is based on the different traffic classes, based on the different traffic classes and their characteristics of the traffic classes and the characteristics of the traffic classes. So what happens over here is here in the region 2, I have listen and sleep, listen, sleep. But you can see here, the listen is not a fixed, only the sleep is a fixed factor, but listen is a variable factor. So the first one may have a longer delay, but the second one may have a shorter delay since I'm varying the listen, but the sleep is getting always fixed. So the energy conservation is almost a constant, but this delay is a variable factor. Here the energy is a variable factor, delay is a constant. Both energy and delay are constant in this particular region 3. And in region 4, both are variable. Some I have a different combination of this listen and sleep intervals. I have a different combination of this listen and sleep intervals. So this has to be noted down as part of this choice of listen and sleep intervals. So something like this, constant and variable factor. There are certain constant factors, there are certain variable factors. So here, how you can try to formulate the problem is, given the PL and PS. What is PL and PS is the power consumption in on and DRX interval. See, DRX does not mean that I don't have any power consumption, because in DRX only I have the listen intervals. So the power consumption in on and DRX interval, what is the minimum value of this T min, T max, L min, L max? What I mean by that is minimum and maximum duration of the DRX interval, minimum and maximum duration of the on interval. And objective is to minimize the energy or average power consumption that is subjected to reduced or average response or packet delay, and it should be less than or equal to the minimum delay of the heterogeneous traffic. So this is how we try to formulate the problem, so that certain things are given as part of the power, certain things are we are supposed to find certain durations. So this duration should reduce the energy. Reducing the energy, we should also try to keep the delay as much as possible. Delay should be a least value or minimum delay of the heterogeneous traffic. So we can able to have the delay and energy bounds as given over here. So the ED, as I already said, it is the average response delay. ED is for a response delay, P is the power consumption. So the response delay or average response packet or response packet delay is bounded between T minimum and T maximum, or L minimum and L maximum over a fixed T or L, or a fixed T or L. Similarly, the power consumption is bounded between T minimum into P plus L into PL, a ratio of T minimum into PS plus L into PL, and T minimum plus L, T maximum into PS plus L into PL, and T maximum plus L. So how this particular thing has been formulated? So something you might come. So how this particular bound has been formulated is by looking into the duration of the minimum and maximum duration of the sleep as well as listen interval. Minimum and maximum interval of the sleep and listen interval. So here, this is for bounds actually. How this value has to be bounded between, because while we are designing any energy conservation, we need to also fix the bounds actually. So how this listen intervals has to be formulated is, having known what is the delay, I can calculate from the T and L minimum. I can calculate what is the minimum listen interval. What I can calculate what is, having known the delay, because a delay is based on a particular traffic. I already said, right? Delay is based on a particular traffic. So having known that, I can find what is the minimum duration, and what I can able to do is I can be able to calculate this for a fixed DRX and variable on. So here I'm keeping the DRX period as fixed and on duration as a variable. Here on duration has been fixed and DRX period has been made variable. So why this particular mechanism has been formulated is to make this delay as an important factor. When I say I'm fixing the DRX, I'm more concerned about maintaining the delay. When I try to fix the on and variable DRX, I'm more concerned about reducing the power. So here my target is in formulating the minimum listen duration. Here I'm minimum DRX duration or minimum sleep duration. So here I try to calculate the values. So as I said, I can map this with reference to different VoIP application and without silence suppression, voice with silence, and reception of video like MPEG video, and non-real-time variable bitrate like FTP and HTTP, and best effort like email applications. So here, what has to be seen over here is what is the data generated interval? What is the interval by which I am trying to generate the data? Whether it's a periodic or it is a aperiodic or dynamic. What should be the packet size based on this application, whether a fixed or dynamic? How the delay sensitive has to be noted down. Having looked into all the factor of data, data generation interval is nothing but the packet arrival rate. See, you know that every packet arrival rate depends on the network as well as based on the application as well as based on the user interactions. So then the packet size is also important. So you know the ATM cells has 53 bytes of packets, 53 bytes of data, and Ethernet has 1500 bytes, and it's a variable factor, 1000 bytes for a standard internet packet. So the packet size is a variable factor most of the time. Sometimes for certain constant bit rate, it is a fixed also. And delay sensitive, already I explained about the sensitivity nature on the applications. So here, looking into this, what we can think of is having a power saving classes. So here, earlier I said about the DRX, but I just go much more deeper into the power saving classes. So basically there are three types of power saving classes. So like type 1 power saving, type 2 power saving, and type 3 power saving classes. So we will see what is the need for power saving. So as I said, most of our mobile will have this power management in terms of power saving classes or DRX mechanism. Both are one and the same with a slight difference based on the duration of listen and DRX cycles. So here, the type 1 power saving doubles its sleep period if no packets are sent or received. So here, it is doubling the sleep period when no packets are sent. So it having a constant sleep and based on round robin fashion, it is a predefined operation. So here, what are the things to be calibrated is the initial sleep window, final sleep window, initiation of awakening. Here I am not going with the timers. It is about the initiation of awakening. So awakening is something like you are in the sleep state. Who has to awake you? Something like who will be awakening the mobile? Basically, when you have any data, you will be awakening the mobile. Sometimes any data has to be delivered from the base station. It is about base station awakening. So this mobile station awakening is done instantly because you take the mobile and start transmitting the data. Base station awakening is not that factor. It is done during listen intervals. The final sleep interval, listening window, and duration of the sleep interval. This duration of the sleep interval is a very interesting factor because it can be a minimum value or it can be a value as a factor of exponential increase of min and maximum duration of the sleep window. Minimum and maximum duration of initial and final sleep window. And while we are looking into this particular thing, we also has to be very careful in looking into the performance parameters. Something like what is the sleep duration, what is the arrival rate, and what about the energy and power and the response delay. So the sleep duration or sleep time is a time in which the sleep mode including one or more sleep cycles, and every sleep cycle includes one sleep duration and one listen duration. So that has to be noted down as part of sleep duration. Lambda is the arrival rate. You know, lambda is the frame arrival rate was user equipment that follows certain distribution. Here the very common thing is to assume it as Poisson distribution, the number of frames per unit time, but it need not to be Poisson. It can be a Weibull, it can be any sort of distribution. Normally, if the arrival rate is Poisson, the inter-arrival rate is going to be exponential distribution, but you need not to follow the same traffic characteristics. We will see on that also. What is the type? for distribution based on the traffic characteristics. So let n denote the number of sleep intervals before the mobile station goes to the wake mode. E is the energy conservation in the sleep mode, and R is the frame response delay or frame response time. So just I put it in a very simple thing, having a wake and sleep mode, wake and sleep. And so this is a not having that complications as we have seen in the earlier one, but this is something like a transition between wake and sleep. As I said, a mobile can be either in the wake state or in the sleep state or in the ideal state. I'm not going into the ideal state of the mobile. Please remember, I'm not going into the ideal state of the mobile. The reason behind this, ideal state is a very different field of research that looks into the paging factors and how this frame has to be formulated based for this particular paging application. So here we look only into the wake and sleep state of the mobile. The sleep state has different duration, having the sleep interval, listen interval, sleep, listen, so on. The cycles is a variable factor. So this one will give you a insight regarding the delay that has to be noted down for different application. Either it is going to be a 5G network based or a 6G or in the case of 4G. So how to reduce the delay? The delay we call it as response delay. Please make a note on that. The delay is called as response delay. What is the need for this particular response delay is, see, basically I should have received this during the listen interval. So then there won't be any delay. So when there won't be any delay, if I'm receiving this particular packet during the listen interval, then there is no delay. But I am in a deep sleep state, so I could not able to receive this, and I could able to receive again only during the listen state. So what happens in this case is I'm going into a deep sleep, which is the cause of this response delay. I'm not responding to the packet that has been received instantly. So here, for that sake, during every listen interval, I just look for the PDCCH packet. If there is no such packet, I say there is a negative indication. Means that I don't have any packets to be received. So sometimes this can be awakened. See, the sleep mode can be awakened if you have any data to be transmitted to the network, here from the mobile station to the base station. So this is this y-axis is mainly like base station to the mobile station. So I said there is two types of awakening. Awakening means who has to wake the user equipment. So in the case of our mobile station initiation of awakening, it is waked in because the moment you take the mobile, you just try to go from the sleep state into wake state. But in the case of the base station initiation of awakening, the delay is an important factor. So here the delay has to be reduced to a greater extent. This delay has to be reduced. This can be reduced if you just put this particular listen not in a predetermined manner, but something in a based on the traffic characteristics. So here the mobile sleep request and the sleep response. So something like a mobile sleep request, mobile sleep response. So after the mobile is in idle state, and then it goes into the deep sleep state. And after having a traffic indication in the listen state, it is going back into the awake state. So it is called as type 1 power saving because the sleep state, here I don't have the concept of short and long DRX, because that short is for some period of time and long is for again some period of time. There is an inactivity timer in short. It is not that way. This type of power saving is mostly used in wireless LAN. This type of power saving is mostly used in wireless LAN gateways. So here, initially I have a short DRX, short cycle, the sleep mode, sleep state has been short. After that, since my traffic indication is negative, I'm doubling the size. So this means of doubling as a factor of exponential of 2, exponential increase. So this is called as type 1 power saving class. So here awake mode and sleep mode has been alternative. The type 2 power saving class is something like I don't double the size as in the case of type 1 power saving. Rather, what I try to do is after this particular waiting time, having the sleep request and response, I go into the sleep state. Then I have an equal window size for everyone. In the case of type 2 power saving classes. In the case of type 2 power saving classes. In type 3, it is a very different one. Having the ranging response, something like this is something mostly activated by the base station. Activated mainly by the base station, where after getting the response from the base station, I immediately go into the sleep. There is a deep sleep state. Deep sleep. And the sleep is without any listen interval. That has to be noted here. Why I call it as a deep sleep? Here in this sleep states, I have a listen interval where I can receive the traffic indication message from the base station. But in this case, I don't have any such provision of receiving the traffic from the base station. So this is something like a deep sleep. And after going into the wake state, after that duration, I receive a response and then I receive the data. There is one more power saving class called as type 4. What do you mean by type 4 is, here I have a, the sleep and listen. You have the sleep and listen. But here, why it is called as type 4 is, so here it combines one or more power saving classes. It combines one or more power saving classes. You can see here, it's very similar to that of DRX, but not exactly the same as that of DRX. So it is combining the sleep cycle of type 1 and sleep cycle of type 2. So how the energy is conserved here? It combines the sleep cycle of T1 and combines the sleep cycle of T2. So it is called as type 4 power saving classes or hybrid power saving class or an integrated. So there are different terms available in the literature with a reference to this particular power saving classes. So the C1 is a combination of L1S1, C2 is a combination of L2S2, and here you can see that this particular active mode has this, but after combining you have this sort of listen interval. So the listen is also not a constant. You can see here, right? The listen is also a variable based on the cycle of the type 1 or type 2. So here is somewhat a higher listen state, lower listen state. So why this is important, I already said. The duration of the listen has an impact on the power or energy. The duration of the particular sleep also has an impact. Here there is a large duration, but here the duration has been reduced a lot. So how they are combining is been shown over here. See, this particular type 2 conventional power saving class type 1, and this one is something like how they are combining. See, in type 2 I have a listen, in type 1 I have a listen. These two are added here. And try to how this hybrid has been formulated. It is not formulated on a simple integrated manner. See, when we say hybrid, it is a different, right? See, we say hybrid vegetables means that it is having a say peculiar features. Sometimes we say like certain fruits has a different taste as that of a conventional one. That's what we call it as hybrid. Integrated is different. We just try to have both the characteristics, but hybrid is something different. So here we can say the listen is getting mapped. So I have a listen. So here I have a listen. Here I have a listen at this point in the case of type 2 and at this duration in the case of type 1. I take a duration which is far away from that of these two. So compare this type 1, type 2 is far away. So I am choosing this particular one. So this one is like combining these two. This particular state of mobile station is combining these two. And I choose this so that I need not to wake up immediately, but at the same time I should not have a response delay. Similarly here interestingly what happens based on this particular, although this is a dominant based on type 2. You can say which is dominant based on type 2. So although this is having a longer value compared to this type 2, this has been chosen based on this particular. And here, this one has been retimed and this is retimed. So something like you can see it may be very similar to that of type 2, but it is not type 2. The reason behind is the duration of the cycle in the case of short duration is getting altered. So, but here, this is only one type of combining mechanism. You need not to go with this based on the delay. You can take the dominant factor as type 1 because you can see the type 2 factor has more number of listen, which has more energy power consumption or less energy conservation. So if you look into the type 1, then you can go for less number of listen, which has a other factor of having a variable listen so that the energy can be conserved a lot with type 1. This is another thing, as I said, hybrid PSM as given by this particular scholars, research peoples, like having PSC1, 2, 1 alternatively. It is not like this hybrid. They call this as alternative arrangement as hybrid. Alternative arrangement as hybrid. So there are other ways of combining. Here the listen interval can be configured in such a way that I can have the listen, which is a variable factor for real, non-real time, as well as for the extended listen time for non-real time. The listen interval itself need not to be always for one traffic. The listen interval can be subdivided, having a for real-time traffic, non-real-time traffic, and extended listen time. So this is another way of having a power saving classes. So what are the issues that is concerned about this power saving classes? What are the issues in the sense of what has to be taken care for this particular power saving? So you can see that there is a weakness of power saving class 1 and 2. That's why they have gone for the hybrid or integrated. So there is an exponential increase or a constant pattern. So need not to be always follow the traffic arrival as poison. We cannot always model the traffic arrival as poison because we have a different traffic characteristics in 4G and 5G. The mobile station load or the data accumulation threshold has to be not taken care as part of this power saving. So this is something like with one type of network, how the listening, sleep, and sleep offset has been defined. So I just put a look into how this web workload characterization or data traffic, how it can be characterized in the case of data traffic. When you see how it can be characterized in the case of data traffic, it is worthwhile to look into the arrival and service rate of the traffic. See, because most of the 5G network or wireless network is mainly focused on this internet traffic. So here, the key properties to be noted down is the message characteristics. So you have, in the case of HTTP, there are several request and response codes to be handled by this particular protocol. So you have different resource characteristics like diverse content. You know, in the browsing, you can browse different traffics in different content types, which has different size and frequency. And based on the behavior of the user, also the browsing also significantly impact the power consumption. So looking into the key properties of this particular web workload characterization, what you can think of is you can go for what should be the arrival. Earlier I said the arrival is mostly Poisson based, but here this distributions, the probability distributions is mostly like exponential for certain session inter-arrival times. The session inter-arrival is mostly taking the characteristics of exponential. The responses or the temporal locality is taking the log normal. The resource popularity. See, resource popularity is all about the identification of the appropriate resources over the web is based on zip file like distribution. And most of the times what happens, the request and response or the number of images, the inter-arrival times is following a Pareto and Weibull distribution. So we just look into this particular one like Pareto and Weibull for this particular web workload models. So here, this is for in the case of our web load or characterization, but we know that we not only look into the web browsing. Most of the times we also try to have a FTP based access like a file transfer protocol in IoT or in terms of wireless network. So here this file transfer protocol is used to transfer files between, we know the basic definition, is to transfer file between two links through a network. So here, this interestingly, this particular FTP is modeled by Pareto and Weibull, or the on state, the traffic arrival state. This is the arrival state is characterized by Pareto distribution, and the inter-arrival state is characterized by Weibull distribution. So here, an FTP is much more characterized by Pareto and Weibull distribution. So once we look into this FTP traffic model, so which is a part of the browsing. So first we look into the probability density function of the on and off period. So what is the on state, how the PDF has been defined. We know in terms of alpha and beta, where alpha and beta are the scaling and shaping parameters of this particular on and off duration in the case of our FTP traffic model. So here, where alpha is the alpha on and alpha of f is the shaping parameter of the traffic, and this is the scaling parameter. So because I'm looking into the PDF, what I can able to define is I can define what is the minimum, what is the duration of the sleep interval, which is given by the minimum of this minimum and maximum duration of the sleep interval. So the probability there is no traffic arrival. So once I say the probability density function gives the scaling and shaping factor of the traffic, what I can go for next is what is the probability that there is no traffic during the sleep interval. So that I need to model. So you know it is based on e power minus t plus l. T is the sleep duration. Sleep duration is t. J, where Tj is a factor of minimum of these values, minimum and maximum, and L is the listen interval, and lambda is the arrival, lambda is the scale factor, and K is the shaping factor. Lambda is the scale factor, and K is the shaping factor. So here, this is the probability. What is the probability that there is no traffic arrival during the sleep interval? What is the probability that there is a traffic arrival? There is no traffic arrival is characterized by that particular probability. What is the probability that there is a traffic arrival during a particular sleep interval? Why this has to be taken care is, you know that I should also see if I have certain traffic during any of this duration. Say example, I have traffic at this duration, how that has to be characterized for this particular traffic, for this particular FTP traffic is given by Pj is equal to e power summation of this value, because I have a n number of sleep and listen intervals into 1 minus e power j. 1 minus is happening this without the occurrence of this particular one. So that is why I have 1 minus of that. So this is the probability that there is a traffic arrival during the sleep interval. So since we say the arrival rate is following Pareto distribution, the inter-arrival is by means of Weibull distribution. So we have to calculate the mean of the Weibull distribution is given by lambda as a factor of 1 plus 1 by k. So the gamma function characteristic is 1 plus 1 by k, where k is this particular shape parameter of the traffic. So here I try to calculate what is the probability of arrival and probability of non-arrival. So having known this, I can able to calculate what is the average number of sleep cycles in overall sleep mode operation, because I need to calculate how much energy is getting conserved. So I try to calculate the number of sleep cycles as a factor of probability of n is equal to j. Means that there is a probability of traffic has arrived over the n number of intervals. So here, the same way I try to calculate the probability of arrival and non-arrival. I calculate what is the energy. At the same time, I also try to calculate the average energy consumption in base station initiation of awakening. So here, this is the number of sleep cycles. Here I calculate the number of sleep cycles, because that has to be calculated to calculate my what is the energy consumption. What is the energy consumption? So the average response delay, having calculating the energy or what is the energy that is being conserved. On the other hand, I need to also calculate the delay associated in conserving the energy, because that is worthwhile, because having say I have conserved this much of energy, I should not increase the delay of the system or network. So I calculate the response delay as a probability of arrival, and here this gives the relation between the with reference to Poisson as well as the Weibull distribution. How it has been calculated in the arrival time is calculated in the case of Poisson, and how it is calculated with reference to our Weibull distribution. Because Weibull is given by means of gamma function. So here, but in the case of Poisson, it is simply the inverse to the arrival rate. So inter-arrival rate is the inverse of the arrival rate of the, in the case, inter-arrival time is inversely proportional to the arrival rate. But it is not the case in the case of variable distribution. So it is given by means of gamma function. So just I have taken few network parameters for investigation, something like what is the frame duration, what is the listen interval, what is the minimum and maximum sleep interval, and what is the sleep indication message, traffic indication message, what is the energy consumed during the listen during energy consumption, what is the minimum value during the listen interval, sleep interval, and transmit mode. So this indication messages says the arrival of the particular message and traffic arrival distribution. Since in the case of this particular FTP traffic, I assume to be a Pareto distribution, and here in the case of traffic inter-arrival, I assume to be a variable distribution. So this simulations has been carried out in MATLAB, and we can do in Java or whatever maybe, so C or C++. So here you can see that seems that inter-arrival is a very important factor to be characterized, because knowing when the arrival of traffic and how this traffic is going to impact the response delay, how the traffic is going to impact the frame response time. Frame response time is the frame response delay. So here the minimum and maximum values of the sleep and wake duration has been taken as a variable factor between 1 to 64 and 1 to 128. And you can also see there is one way of adaptive power saving, which is trying to combine the power saving classes. And you can see that during the initial arrival times, what to be noted down is during the initial arrival times, so say there are different factors that has a different interpretation over the results. So if you look into this T minimum as 4 and T maximum as 128, during the initial arrival time, I have a very huge response delay that can be inferred over here. But as the inter-arrival time increases, it is not having that much exponential decrease, but there is a reduction in the delay. But if you look into these values of this minimum and maximum, interestingly, during the initial values of the inter-arrival time, it is having a very low value. You can see that, right? During the initial of the minimum and maximum sleep duration, it is having a low response delay. But as the inter-arrival time increases, inter-arrival means the duration in which I'm expecting certain traffic increases, the delay increases to a very larger extent. That is a very important factor to be noted down. And so when you have some adaptive mechanism and you can able to go with these two means, actually what it means is I can able to control this particular one so that I can able to reduce the response delay and by means of some adaptive mechanism. That's the adaptive PSM that has been noted here, where there is inter-arrival time is a factor and that reduces the response delay. So interestingly, the response delay should come without having any compromise with the reference to our energy consumption or energy conservation. So as I said, the energy consumption is very high with reference to more inter-arrival time as inter-arrival time increases, because we are also trying to put forth with certain means I'm trying to increase the listen interval. Certain means I'm increasing the listen interval. So the energy consumption is increasing. But in certain points, what I can able to do is I can have a trade-off saying that I can reduce the energy consumption in this case with an adaptive mechanism, or say certain things like with these values of minimum, by increasing the minimum or certain cases, I can reduce the energy consumption. So here, this is a general HTTP model. Then I said about the FTP traffic model, then a web traffic model. So web traffic, this is very interesting because this is again interestingly follow the Pareto, but it is not having the Pareto distribution as in the earlier case. What do you mean by Pareto distribution is having the Pareto during the on state. Here you can see, right? You can see the Pareto during the on state and variable during the off state. But in the case of web traffic, what happens is it is not having such things. The Pareto is in the on state, the Pareto is in the off state. So, or variable in the on state, variable in the off state, or a different traffic characteristic is being observed in the web browsing source. And more interestingly, the data packets arriving is also a variable factor. Data packets arriving is also a variable factor. So normally the moment nowadays we just if we have any doubts, we just open the Google and try to browse or search for certain information over the internet, and that is highly characterized by the user interface. So here normally what happens is the Pareto distribution is characterized by the scale, shape and location parameter. So earlier we are concerned only with the scale and shape parameters of the traffic, but now we are also concerned with the shape location parameter, alpha, lambda and mu. So the shape parameter is also known as the tail or Pareto index. So this is something like looking more into the traffic, then we try to put the traffic or we try to model our power saving mechanism for this energy conservation. So that is the idea over here, because the more we look into the traffic characteristics, we have more insight in defining the power saving model. The Pareto distribution is a power law probability distribution that coincide with the social, scientific, geophysical, and many other observable phenomena. So that is really interesting, right? So instead of having like Weibull and Pareto, here the Pareto has been more investigated, and in case of field of economics, outside the field of economics, it is also called as Bradford distribution. The Pareto is also called as Bradford distribution. So it is characterized by this scale, shape, and location parameters. And the shape parameter is also called as a tail of the Pareto or tail of Pareto index. So this is the one figure that gives us some insight into the research. See here we assume in terms of certain what is the type of device. We are not looking into the number of devices that I need to put forth here. If we, as I said, there are more number of devices that is coming into the picture, everything has to be reiterated. This is only with one device for the sake of simplicity, and the traffic characterization with reference to that particular device. But when it comes to a gateway functionality with many devices, that is really going to be a big research opening with reference to that. So here this log plot for the web and voice transmission is given over here. You can interestingly you can see in the case of voice, the tail of the traffic has been having a sharp reduction, but the tail in the case of web is a heavy tailed traffic. So this is a point of investigation to be noted down when we try to characterize this sort of traffic. So looking into how what are the things to be noted down in the traffic is how the main part of the traffic as well as the tail of the traffic is also playing an important role, because this traffic, although containing few bytes of information, this will be providing the acknowledgement sort of services, synchronization sort of services to the end devices. So if we are not catering to this particular section of the traffic, we may lead to having a system having more delay in the network. So this part has to be noted down. So I just compared between the voice and web traffic, where you can see the tail, which is a light-tailed traffic in the case of voice and heavy-tailed traffic in the case of web applications. So again, there are some common means by which we try to calculate the energy and power. We try to first calculate the inter-arrival time, and then we try to calculate the mean, and then the mean of the Pareto distribution. Because I just put forth how the inter-arrival time is varying for the Poisson, Weibull, as well as Pareto distribution. Because you know that here there is one more factor called as a location parameter as compared to the scaling and shaping parameters. In addition to the scaling and shaping parameter, I have one more parameter called as the location parameter, which is going to be playing a vital role as part of this. So here, because for this type of traffic, this alpha is a function of this location parameters. So there again, we try to calculate what is the probability for calculating the sleep cycles and what is the number of sleep cycles, the probability of the sleep cycle and probability of the number of cycles, which we calculated with reference to the bounds, and then what is the energy that is being getting consumed due to the lack of time. I just put forth what are the things that is being calculated. This is the average energy consumption during the base station initiation of awakening, and what is the response delay. So these are getting calculated. There are some few steps behind. I'm not putting all the steps involved in the calculation of this particular derivation. It's only it's very simple steps. It need not to be that complicated. So here you can see that here how this response delay is a factor of in this particular traffic when compared. So see this particular one where I have an increase and a decrease and sudden increase. So this is really an alarming factor, or this is the point where researchers can much focus due to the tail of the traffic, due to the distribution of tail of this particular web traffic. So normally we expect either an increase or normally the curves of many like BER or many other performance curves either have increase or decrease. But interestingly, the delay is very high for certain for the initial inter-arrival times and a least value for this particular region of inter-arrival. Suddenly there is a very huge delay, and for this minimum and maximum. For certain values of T2, the listen intervals, I can able to keep this particular one as a very smaller value. See, this dash dotted line is don't having a variable factor of listen. When I have a variable factor of listen, I can keep the delay. But interestingly, what happens? This also increases the energy. And there are certain regions of adaptations also. Regions of adaptation means there is a crossover being observed here and here for certain values of this minimum and maximum sleep duration and listen durations. So the energy consumption reduces and then increases as seen in this case of our traffic, web traffic. So this gives different power saving classes that has been examined with the different values of minimum and maximum sleep durations, a number of sleep intervals that has been made observed over here. See, the idea over here is what we can understand by populating these values is, see, the sleep interval should be not, if it is minimum, it is not that maximum is not an important factor. With the minimum, whether we can able to get a minimum delay. So you can see the minimum delay is here 0.6449 or 0.453, but that is not an interesting factor because where I'm getting the delay with the reduced number of sleep and energy consumption is the point of investigation. So as I said, there is a trade-off between this delay and energy consumption with the number of sleep intervals, and also has been taken for adaptive. This is for FTP traffic. This is for web browsing traffic. You can see that for certain values of 8 and 1512, for certain values of minimum and maximum sleep duration, the number of sleep intervals and response delay has been obtained as part of this web browsing traffic. So why these values are important is once we know this, we can able to set these values as part of our device parameters so that will reduce the energy consumption. That is a general idea. So once the device can able to reduce energy, the network can able to facilitate the devices or network with reduced energy consumption. So when we look into a standalone wireless LAN, again I have a variable factor of this power saving models. So whatever we have seen is what given, but the terms or terminologies will be different in the case of our wireless LAN. We call it as a beacon interval. We don't call it base station. We call it access point. We have certain 18 arrivals, and this particular advertisement sniff interval advertisement. So this is in the case of Bluetooth low energy model. Bluetooth. See why this Bluetooth low energy came is this Bluetooth low energy can able to conserve a lot of power when compared to the conventional Bluetooth protocol stack. So this is in the case of wireless LAN, where it is given by means of 802.11 power saving models. I'm not going detail into it, but just a glimpse of it. Wireless span mainly in the case of Bluetooth low energy sniff mode. Sniff mode is the mode to be activated when you want to conserve a lot of energy. And there are really so much of challenges based on the number of devices in the network, their traffic variations. So there are so much of challenges where the researchers can really look into this particular region of energy conservation. So as I said, looking into the tail of any traffic. So if you look into the LTE, so this one slide will give you more interesting fact about the power management. LTE consumes more power than 3G 5G in high power time. So I already given you the traffic low tail and high tail, right? So LTE is consuming more power where in high power tail, because for instance, during the high power tail, a Wi-Fi tail, 3G tail and LTE tail, which is having more power getting consumed, it is LTE. On the other side actually, LTE high throughput compensates for the energy on the tail. So you can see, right, this fact is really interesting. When I transfer a data of 10 KB, so who is taking more power? LTE. See, LTE is taking 170 microjoules per bit for transmitting a small data file. Interestingly, when I try to transfer 10 MB of data, LTE is taking only 0.3 microjoules when compared to this 3G. So that is really interesting and really worth investigating the traffic and the resources or resource blocks as part of its LTE, Wi-Fi and 3G. So energy bit comparison, you can also work on more of these 5G networks for M2M or machine to machine or D2D devices. How this is happening for either a data or transfer size, because this transfer size has not been investigated earlier. I'm just looking into the inter-arrival times only. But if you want to look into the transfer size, this is really interesting, right? So everyone, here I said LTE is consuming more power in high power tails, and this is a real fact. But when compared to the lower data getting transmitted, higher data getting transmitted, LTE is consuming less power. So that is really an interesting fact when compared to our Wi-Fi. Wi-Fi, anyhow, it is going to consume less power due to the short range when compared to the LTE. And normally we compare LTE with 3G, where this 10 KB is 100 microjoules per bit. Here it is 4 microjoules per bit. So conclusion on this part of data transfer is small data transfer, LTE waste energy, but it is a large data transfer. LTE is highly energy efficient. That we have to accept, and this is a proven concept with reference to the data transfer. So which technology to be, or which network has to be chosen for various solutions, what I have discussed earlier with reference to the earlier perspective. You can go for either Wi-Fi, Zigbee, LoRa, cellular, Ethernet or Powerline or low pan. Based on this particular, you can design what how much power to be consumed. So certain things are highly feasible. Say example, Wi-Fi just widely deployed, can be deployed with many of the applications. Zigbee, except smart and agricultural, even agricultural control panels, it is not normal. Agriculture is highly deployed actually. That's all to have. And these are a few of the references. Mostly you can go and look into the 3GPP forum as part of this particular energy conservation. So that's all from my side. If you have any doubt on this, feel free to.
Thank you so much, sir, for that informative session. May I now request any of the participants, if you have any queries or questions, please put in forth. You can unmute your mic and speak.
Even you can put your queries in the chat box.
So some of these models may be very new, or some of you may be working on these models. So this is one of the areas even in 5G where more focus is being done in current networks. And see, if you take wireless LAN or LTE or even 5G as part of like one dimension is for energy conservation. So
Okay, thank you, sir.
okay, ma'am.
We will be sharing the resource person details in shortly, so that if any questions you have to ask, you can ask through that. Okay. Here we have come to the end of the 5 days FTB program on recent trends in medical imaging and communications organized by the Department of Electronics and Communication Engineering in association with Department of Computer Science Engineering and Information Science and Engineering. Before we begin with the validatory function, may I request our dear participants to share their views or feedback on this FTP. Over to you, participants.
Hello everyone. Hope I am audible.
Yes, sir, you are audible.
This is Guru Raj from Department of Computer Science and Engineering, MIT Manipal. Regarding the workshop, it is well organized with highly informative information contents, and moreover the expert persons in the relevant area. So throughout the 5 days, and some of the topics covered, especially medical imaging and other things, the near topics are well defined, and those who are in the field of research in these topics, I hope most of them got the information related to their research work, maybe at the initial stage or some of the later stages of their research work. So it was well organized. I thank all the organizers from the AJ Institute of Technology, the Department of Computer Science and Engineering, ENC and Information Science. I hope all of you put your effort to organize and conduct this workshop in a more beneficial way to the participants. And as a request, I request the organizers, if possible, to share some of the resource materials to the participants. Overall, it is well organized, more informative, especially to the community of researchers. Thank you.
Thank you, Guru Raj, sir, for sharing your views. Definitely, we'll be sharing the resource materials. Any other participants? Please share your opinions.
Hello, ma'am. I'm Shivani.
Yes, Shivani, you're audible.
The FDP was neatly organized. I would like to thank AJ Institute of Engineering and Technology for organizing this FDP, which helped us to gain lots of knowledge in the medical imaging processing, which I can further make use in my upcoming projects. Thank you.
Thank you, Shivani. Any other participants? Okay. May I now request our program convener and head of the Department of Electronics and Communication Engineering, Dr. Gnaneshwar Nath Sadhupati, to express his views and remarks on this FTP. Over to you, sir.
Thank you, ma'am. Respected President Dr. Rajesh Shetty, Vice President Mr. Prashant Shetty, Directors of LMAIT, Principal Dr. Shantaram Rai sir, HOD and ISC, Vice Principal Dr. Nagesh HR, HOD of CSC, Dr. Anthony PJ, and other head of the departments, participants, and my dear faculty. A very good morning, afternoon to all of you. From last 5 days, we have witnessed a wonderful session on recent trends in medical imaging and communication from eminent personalities from industries as well as academia. Medical image processing by Dr. Harikrishna Rai, extension from 2D to 3D for visual understanding by Dr. Raghavendra U, overview or power management IC by Dr. Vasudev Reddy, machine learning for wireless communication by Dr. Prashant Kumar H, energy conversion in wireless networks by Dr. A. Rajesh. My heartfelt thanks to all resource persons for this wonderful session. We had around 250 plus participants from all over the country in all these 5 days who participated actively through Google Meet and one YouTube platform. I would like to thank all the participants for being wonderful audience. At this note, I would like to thank the management, our principal, Dr. Shantaram Raisi, Vice Principal, Dr. Nagesh HR, and HOD of CS, Dr. Anthony PJ, for their constant support, encouragement, and cooperation extended to make this 5 days FDP a grand success.
Thank you, sir. Gratitude is the greatest essence of respect and appreciation. On behalf of AJIIT family, as a token of gratitude, it gives me immense pleasure to propose the vote of thanks to the eminent speaker of today, Dr. Rajesh A. Sir, for such an informative session on energy conservation in wireless network. Thank you, sir. At this outset, I would like to thank our honored President of Lakshmi Memorial Education Trust, Dr. A.J. Shetty Sir, our honored Vice President, Mr. Prashant Shetty Sir, Directors of LMET for being the patrons of this FTP and also their support in abundance for such happening events in our college. I would express my sincere gratitude to our beloved principal, Dr. Shantaram Raisi Sir, who has been giving us constant guidance, support, and motivation throughout, which is our highest strength to come up with successful events like this. My profound thanks to our program convener and head of the Department of Electronics and Communication Engineering, Dr. Gnaneshwarnath Satyapati Sir, for taking up this initiation, implementing and executing it in a very proficient manner. Thank you, sir. I express my heartfelt gratitude to our Vice Principal and Head of the Department of Information Science and Engineering, Dr. Nagesh HR Sir, and Head of the Department of Computer Science and Engineering, Dr. Anthony PJ Sir, for their extended support for this FTP. Thank you, sir.
Thank you, Vatiksha Madam.
Thank you, sir. A good dedicated team of program organizing committee as well as technical committee also bears a good applaud for the success of this event. Thank you, team. It's my pleasure to thank all the teaching and non-teaching staff of AJ Institute of Engineering and Technology for contributing their support. Last but not the least, dear participants, you have extended your keen interest in learning as well as extending your full cooperation for this 5 days FTP program on recent trends in medical imaging and communication. And we are all happy that we're all part of this FTP with us here and making it a successful one. Thank you for being a great audience and also expecting your cooperation for our upcoming events as well. Certificates will be sent to your registered mail ID at the earliest. With this, we sign off. Thank you.